It is students. On this clip, we're going to be going over questions 21 to 25 of the Integrated Algebra Regents exam for January 2013. This is part 5. We're going to go ahead and start with question 21. Alright, so on question 21, it states if x equals -3, what is the value of the absolute value of x minus 4 minus x squared? So this is assessing our understanding of the absolute value property and also how to simplify the squares of negative numbers. Alright, so let's go ahead and substitute the value of x into this expression. So it's going to become the absolute value of -3 minus 4 minus -3 squared. Okay, I just substituted the value of x into these two x's here. Alright? Okay, so let's go ahead and simplify this. These two are negatives. We add and keep the sign. Negative absolute value of -7 minus. Now, anytime you square a negative number, the power, it becomes a positive, okay? Or a general rule is if you raise a negative number to an even power, the minus, the negativity goes away, okay? Because all the minuses pair up, and when you multiply two minuses, you have a positive, all right? So if you square the minus, it becomes a positive, and when you square 3, you have 9. All right, let's simplify this further. Now, the absolute value of -7 basically means how far is -7 from 0 on the number line. So that's going to be 7. All right, absolute value is not the opposite. It's just the distance from 0, and it's always a positive value. All right, so we have -7 minus 9. 7 minus 9 equals -2. So we can see that our answer is option number 2. All right. All right, let's take a look at question number 22. It says, which equation um, represents a line parallel to the line whose equation is negative, is 2x minus 3y equals 9. So if two lines are parallel, they have the same slope, okay? All right, so if I can determine the slope of this line, then I can see which of these slopes has the same slope, all right? All these equations, the options we have here are in slope-intercept form, y equals mx plus b. So the coefficient of x is basically the slope for these equations here. So in this case, in this line, the slope is 2/3. The slope here is 3/2. The slope here is negative 3/2. And the slope here is negative 2/3. Okay? So the slope is always a coefficient of x when the equation is in slope-intercept form. -4 is the intercept here, 4 is the intercept here, -4 is the intercept here, and 4 is the intercept here. Well, the equation that we're comparing these slopes to is in standard form, all right? So we have 2x minus 3y equals 9. Now, there are two ways of doing this. I can transform this into slope-intercept form, or I can use a shortcut, okay? Anytime you have the equation of a line in standard form, the slope can be found by using the formula m equals -a over b, okay? What is a and what is b? Well, a is the coefficient of x, as you can see here, and b is the coefficient of y, all right? So in this problem, a is 2, and b is -3. All right, so if I plug these into this equation, I'm going to have the slope equals -2, which is a over -3. When I simplify that, I'll have minus of a minus is plus, so it's simply 2/3. Okay, so a line that is parallel to this line must have a slope of 2/3. If two lines are parallel, then their slopes must be equal. So which of these have the slope of 2/3? You can clearly see that it is option number 1. All right, so this is one way of doing this. You can call this method 1. Let me show you another way of doing this. This is like a quick way if you remember the formula. But if you do not remember the formula, you can also do this problem by transformation of the equation, okay? Okay, so let's go ahead and try out method 2. So method 2, you might like this one if you do not remember the formula -a over b. So method 2, I'm going to basically transform this equation 2x minus 3y into slope-intercept form. And to accomplish that, I need to isolate y. To isolate y, I need to subtract 2x from both sides and divide by -3. Alright, let's go ahead and do that. So we subtract 2x from both sides. It yields -3y equals -2x plus 9. And then you divide every single term by the coefficient of y, which is -3. Divide this by -3, divide this by -3, divide that by -3. Alright, so let's simplify that. This yields, this one's divide out, y equals, minus of a minus is plus, you can just slash and dash, 2/3 x, plus of a minus is minus 3. Okay, so in this line, the slope, we can clearly see is 2/3. So any line that has the same slope as 2/3 is going to be parallel to this line. So we can clearly see that the answer is option number 1 again. Alright, so this is just another way of doing it by transforming the equation from this standard form into this form right here is known as your slope-intercept form. So by making the transformation, you can also determine the slope. Alright, so there goes 2 ways of doing it. Let's move on to the next question. Alright, so in question number 23, it says which ordered pair is in the solution set of the system of inequalities y less than or equal to 3x plus 1 and x minus y is greater than 1. So anytime you have a set system of linear inequalities, the solution region, if it exists, is normally a region where you have an infinite collection of points. So the question is, which of these points resides in the solution region of this system of linear inequalities? So one way we can solve this equation is by graphing these two inequalities and then seeing which point resides in the region. Which will take us some time, but we can do this by also testing each point to see which generates a true statement in both substitutions. Okay, so I'm going to use a test approach. It's a little bit more efficient than actually graphing, but we can also graph too. Okay, so let's do the test. So I'm going to have the equations on the right, and then I'm going to put the test points as the columns. All right, so the first equation we're going to be testing is y as less than or equal to 3x plus 1. Okay, so we can make a chart to organize our tests. So I'm going to put my system of linear inequalities in the first column, and then my test points I'll put in subsequent columns. So first point is option 1, -1, -2. Well, we know that the first coordinate is x, this is x, and this is y. So if I plug this into this equation, do I have a true statement? That's the question. The question is -2 less than or equal to 3 times -1 plus 1? Is it? Let's simplify. Is -2 less than or equal to -3 times 1 is -3 plus 1? And it is -2 less than or equal to -3 plus 1 is -2. So -2 is equal to -2. So the equal component of this inequality holds, hence the statement is true. This equation is true. Alright, let's test the second equation. Now note that the solution point must satisfy both equations, not just one. Okay? Alright, so we're going to test the next one. The second equation is x minus y is greater than 1. Using the same point, if we plug it in, is -1 minus -2 greater than 1? That's the question. Multiply these two minuses, slash and dash, minus times minus is plus. Is -1 plus 2 greater than 1? -1 plus 2 is 1. Is 1 greater than 1? Absolutely not. 1 is equal to 1. So this point does not satisfy the second linear inequality, hence it's not in the solution region. Alright? So we're going to shift to option number 2. Option 2 is are the coordinates 2, -1. Okay, this is my x, and this is my y. Now let's test the first equation to see if we have a true statement. So is -1 less than or equal to 3 times 2 plus 1? Is this a true statement? Is -1 less than or equal to 6 plus 1? Is -1 less than or equal to 7 is the question. -1 is less than 7, so the less than component of this inequality holds, so the statement is true. Alright, let's see if this coordinate satisfies the second equation. If it does, that'll be answer. If it doesn't, we'll move on to option 3. Okay? So the question now is 2 minus negative 1 greater than 1? Minus times minus slash and dash is a plus. So is 2 plus 1 greater than 1? 2 plus 1 is 3. Is 3 greater than 1? Absolutely, 3 is greater than 1, so it checks out. So since this coordinate holds true for both linear inequalities, that means it satisfies the solution region of their intersection. Okay? So we can clearly see that the answer is option number 2. If it didn't hold, we just keep testing each and every one until one holds. Okay? Alright, now let's move on to question 24. It says, which equation represents a line that passes through the point negative 3 comma 4 and is parallel to the x-axis? Okay, so if you want to write down the equation of a point, equation of a line, you need two things. You need the point, which is provided, and the slope. So how do we find the slope of a line that's parallel to the x-axis? If a line is parallel to the x-axis, it has the same slope as the x-axis. So the question is, what is the slope of the x-axis? Okay, so let me introduce you to someone known as a slope guy. Mr. Slope Guy helps you remember your slope. So let me show you how to sketch him real quick, and we'll use it right here. So you start with a positive going up, and then these are the eyes of Mr. Slope Guy, and then you have the nose with a U right there, and an X, and then you have the mouth, horizontal line, two zeros, and then the Y. Okay, so there goes Mr. Slope Guy. What it tells you is that a line going up has positive slope, a line going down is negative. A vertical line is of the form x equals blah and is undefined, and the horizontal line is of the form y equals and has zero slope. Okay, so since we're dealing with the x-axis, what kind of line is the x-axis? The x-axis is a horizontal line. Okay, so with this chin right here, this y, it tells me that the answer is going to be y equals something. But what could it be? The only choice is the y coordinate of the point. So we can easily see that the answer is y equals 4, which is option 3. Okay? Alright, I just used the shortcut method. Now let's do it the long way. Alright? So we're going to use the slope and the points to write the equation of the line. Using Mr. Slope Guy, we know that a horizontal line has zero slope, as indicated by these two zeros, and a vertical line has undefined slope. Okay? So if a horizontal line has zero slope, that tells me that m, the slope of this line, has to be 0 because it's parallel. Okay, we have m. Now what on earth is b? We do not know. So what we'll do is we're going to use m equals 0, and x equals negative 3, and y equals 4. We're going to plug this into our y equals mx plus b equation to find b, and then use b and m to write down our equation. Okay, so we have y equals mx plus b. We need to find b, so y is 4, m is 0, x is negative 3, plus b. Alright, so if we multiply it out, 0 times 3 is 0, so b equals 4. So if b is 4 and m is 0, if we plug it into the y equals mx plus b equation, we can clearly see that our equation is going to be y equals 0 times x plus 4. 0 times x is 0, so y equals 4 will be our final answer. Alright? So we can clearly see that our answer is option number 3. Okay? So y equals 4. So that goes two ways of doing the same problem. Alright? Okay, now let's move on to question number 25. So question 25, it says a cube with faces numbered 1 through 6 is rolled 75 times, and the results are given in the table below. Based on these results, which statement is true? So, as P odd less than P even, P3 or less than P odd, P even less than P2 or 4, P2 or 4 less than P3 or less. So how about we determine these individual probabilities first, and then we can then compare the magnitude of the resulting probability fractions to see which of the statements is true. Alright, so let's compute what these probabilities are. Probability of odd is, remember, definition of probability is possible outcomes over total number of outcomes. So probability of odd is all the possible odd outcomes. So let's see, odd is 1, 3, 5. All right, so it's uh, for 1 we have 7, plus 3 we have 14, plus 5 we have 20. These are the possible outcomes that are odd, and then total number of outcomes is 75. If you add all these numbers together, you get 75. All right, so when we add the numerator, we have 41 over 75. Okay, next one, let's do p even. I'm just determining the probability of each option in my alternative so I can then compare the magnitude of the fractions. All right, so probability of even, we have 22 for the 2. This is even right here. 22, and then 4, we have 6. And then for 6, we have 6. Over, this is possible outcomes over total, which is 75. 22 plus 6 is 6. Is 34 over 75. All right, next one is probability of 2 or 4. Whenever you have or, you just simply add your probability. So probability of 2 is 22. And then probability of 4 is 6. So 22 plus 6 over total number of outcomes, 75. So this is going to be 28 over 75. And then probability of 3 or less is going to be 3 to 1. So 3 is 14, 2 is 22, and 1 is 7. Divide by total number of outcomes, 75. And then if you add 14 plus 22 plus 7, you have 43 over 75. Okay? All right, now let's compare the probabilities. So for option 1, we're told that P odd is less than P even. P odd is 41 over 75. Is it less than P even, which is 34 over 75? Look at the numerators. This is false, because 41 is greater, so this is wrong. All right, let's take a look at option 2. Option 2 says P of 3 or less, which is 43 over 75, is less than P of odd, which is 41 over 75. What do you think? Is this true or false? The statement is absolutely false, because the numerators, this is no less than this. 43 is greater. Okay? All right, option 3, P of even, which is 34 over 75, is less than P of 204, which is 28 over 75. Look at the numerators. Is this statement true or false? It is absolutely false. So the last answer, the correct answer has to be 4, or else we made a mistake somewhere. Okay, so let's compute it. I'll make the comparison. Probability of 2 or 4 is 28 over 75. Is less than probability of 3 or less. 43 over 75. Compare the magnitude of the numerator. This is less than this. Absolutely. Statement is true. So we can clearly see that our answer is option number 4. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here so you can get updates to the upcoming installments of this review series. And please post a comment to let me know what you think about this presentation. And click like if you liked it. More clips can be found on algebrastrand.com. Thanks again and have a wonderful day.